Hey everybody, this is Mr. Munson, and we are in Unit 7, right triangles, and we're going to do 7.3 trig functions, okay? So what this is going to allow us to do is find particular lengths, like in this case, the height of the tree. If we know what the angle is, in this case, let's say 40, if I was standing someplace and I looked up to the top of the tree and it was a 40-degree angle, we have ways of measuring that with our portable phones, to believe it or not. And I'm 75 feet away from the base of the tree. I can use just that one length and that angle, and I can find the height of the tree. All right, let's go ahead and get started. All right, let's just do a real quick review. If I was standing where angle A is, okay, and I wanted to ask you which side is opposite angle A, you should be able to say it's BC, okay? If I asked you which side is the hypotenuse, doesn't matter which angle I'm standing at, that will always be the hypotenuse because it's across from the right angle in a right triangle, okay? And then if I asked you which side was adjacent to angle A, it would be this one. Now, the hypotenuse is adjacent as well, but we already know that as being the hypotenuse, so that's not the adjacent side we want to deal with. Now, all this changes if we go and stand at a different location. If I'm up at B, the opposite side is now AC, which is different than when we were standing at A. And the adjacent side is this one. Of course, this is still the hypotenuse, okay? Now, dealing with if I was standing at C, I have two adjacent sides, these two sides, and the opposite side of the hypotenuse. All right, let's move. So as we look at our trig functions, these are specific equations that we're going to need to learn and keep in our memory, okay? So since these are equations, I'm going to suggest that you take a few seconds and write these onto your blue sheet, your blue formula sheet to have as a reference from now until the end of the year. Of course, you're going to have to memorize them. That's just the way things are going to be. So this right here represents an unknown angle. So in a triangle, we have two angles that we'd be looking at, and it's the two acute angles, not the right angle. So this represents an unknown, just like X and Y are unknown sides and things like that. This can represent some 39 degrees, 42 degrees, some angle inside the triangle, okay? O stands for the opposite and hypotenuse. In other words, the left side of this equation, the sine of this angle, should be equal to the ratio opposite over hypotenuse, okay? Depending on what angle you're looking at, the opposite side is going to be possibly different than some other angle, okay? So you got cosine of this some angle is equal to the ratio, the fraction of writing an adjacent side to the hypotenuse, and the tangent is opposite over adjacent. All right, let's practice coming up with the ratios, making sure we understand which sides we're talking about and memorizing, okay? So the sine of A, so I'm standing at A and I'm looking from that perspective. Sine is opposite over hypotenuse, so you should write that down whenever you're dealing with this kind of scenario. And so the sine of A is the opposite over the hypotenuse. So I'm going to write BC over AB. All right, let's do the next one. Cosine of A is equal to adjacent over hypotenuse, okay? So let's see if we can figure that out. Adjacent, and then of course the hypotenuse is still the same. So we have AC over AB. All right, now let's do tangent. Tangent is opposite over adjacent. So again, we're looking from A's point perspective, so opposite over adjacent. So that would be BC over AC. And there we have it, okay? All right. All right, now it's your turn to do it. Now we're looking at it from the perspective of B. So you're standing now down at B and dealing with opposite, adjacent. Hypotenuse is always going to be the same. Okay, put me on pause and see if you can do this on your own. All right, for me, I always write down those clues, just so I can kind of look at it. And so opposite of B is AC, and the hypotenuse is AB. It's that easy. That leaves me the adjacent side to angle B is the side BC. And of course, the hypotenuse is still AB. And the tangent is going to be AC over BC, opposite over adjacent. Okay, so let's take a look at this one. So here's your I can statements. So you need to make sure by the end of this little segment, you should be able to do all these, okay? So we're writing these trig functions. Now we have the angles in place. And so I want to make sure you know where, if you're given the angle information, where in the equation do you put it, okay? So I'm going to take this triangle and I'm just going to write my trig functions for each one of them. Let's start with from the perspective of A, okay? So I'm looking up here at A. I'm standing up here at A. So opposite and adjacent and hypotenuse from that perspective. Okay, so the first one, the sine of the 53.1, that's where the angle information goes, right? Right after the word sine. Sine of that angle is equal to 6/10, which I reduced to 3/5. Cosine of 53 degrees, and again, we're just standing up here at A, right? The cosine of that angle, 53.1, is equal to 8/10, which again, I reduced that to 4/5. Yike, I totally made a mistake there. Should be cosine. There we go. And then the last one, tangent. And there that is. Okay, now it's your turn. I want you to go to angle C and write the trig functions using that 36.9. Okay, so everything changes, opposite, adjacent, and hypotenuse, of course, stays the same, but using 36.9. Okay, go ahead and put me on pause and we'll check our work. Okay, so I hope that you were able to write those trig functions in the sense from the perspective of angle C. Okay, now what I'd like to do is I'd like to tell you about Sohcahtoa. It sounds like a cool name, doesn't it? But really, if you can remember Sohcahtoa, it'll help you remember these trig functions. You see, the sine function is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the last one, tangent, is opposite over adjacent. Okay? So if you can remember Sohcahtoa, it's 9 letters long, right? Because there's 3 pieces to each one. Then that'd be great. Hey, listen, when you're writing your trig functions, always remember to put an angle in there, okay? All right, so now let's start applying this. Okay, so I've got a triangle here, and this is definitely not a 30, 60, 90 triangle. Okay, so I can't use my sum of triangles. It's not a Pythagorean theorem problem because I only know one side, but I'm still looking for x and y. Okay. All right, well, let's start by doing this. I know what this angle is. This angle here is 36.9. And so I'm looking at this unknown of x. So what I need to do is write some kind of equation that relates to that x, okay? So from D's point of view, from this angle right here, this side right here, the x, is an adjacent side, okay? So I start thinking through my trig functions and think which trig functions have adjacent in them. So I end up with 2 equations, right? Cosine has adjacent in it, and tangent has adjacent in it, okay? So I could try to use either one of these equations, but one of them is going to cause me another problem, and it's this tangent one. The reason is because I don't know what the opposite side is. It's unknown. So I'd end up with a y over x for this equation. That's 2 unknowns. I might have the angle of 36.9, but I have 2 unknowns over here, so that equation becomes void. Okay, so my preferred one is going to be this cosine of the angle is equal to adjacent over hypotenuse. So all I want you to do right now is put me on pause and write the equation, filling in for the angle. We don't know what that adjacent is. That's x, and put 5 in for the hypotenuse. Just write that equation. Put me on pause. Okay, so hopefully you have that written out. So now it's a matter of solving for that x. To solve for that x, I'm going to do like I always do. If one side's a fraction, I just make the other side a fraction and I cross multiply. When I cross multiply, I get that x equals 5 times the cosine of 36.9. I always put the cosine last, or the sine, whatever the trig function is, I always put it last and put the number that I'm multiplying out front. Okay? Okay, so once I do that, it's time for my calculator. Now this next step is so very important. Every time from now until the end of the year, when you pull your calculator out, I want you to first hit the mode key. And then what you're going to do is you're going to go down here to where it says radians. If you look at my calculator, radians is flashing. We have to be in the degree modes. It's like the units that we're dealing with. We don't deal in radians in this class. That's trigonometry later on when you get to that class. Okay, so you need to make sure that degree is selected. Okay, if you don't do that, you get the wrong answer. All right, back to our screen. So now it's just a matter of typing it in. 5 times the cosine of 36.9. I'll close my parentheses there, equals 3.998. And depending on where the decimal is supposed to be rounded to, would determine what I write down. Okay, let's just say we're looking for a whole number, the nearest whole number, and that would be 4. So this is what I know. X is equal to 4. Okay, so now what I want you to do is I want you to find y. Okay, so let's go find y, and we have 5 for the hypotenuse. We have the 36.9. So now we need to figure out which trig function relates the opposite side to the hypotenuse. Okay, so what I want you to do is just go ahead and write this one out. If you can't do this on your own at this point, you want to put me on pause and go back and watch and listen to me set this one up. Okay, watching me do it again is not setting anything into your memory. You're setting yourself up for failure. That's just plain silly. That's the 7th, 8th grader. You're now in 9th, 10th, maybe 11th grade. You need to start thinking this stuff on your own. You can do it, I promise you. Put me on pause. See if you can write the trig function that relates opposite to hypotenuse to this angle. Write the equation, and then you can come back and check to see if you got the right equation and how to do the cross multiplication or do the whole thing on your own. All right, there you have it. So now it's just a matter of plugging it into our calculator correctly. All right, and so we end up with, y being equal to 3, as you just saw my calculator as it disappeared. Okay, so my triangle that I'm given here has a 3 for this side, a 4 for this side, and a 5 for this side. Classic right triangle. Okay, so the last idea before you hit the homework here. So I'm given this right triangle. Sorry for the sloppy mess there. So I'm given this right triangle, and I'm looking for the angles. So this is not a Pythagorean theorem problem because there's no way of solving for the angles. Okay, there's no indication of why I would believe this is a 30, 60, 90 triangle and so on. Okay, so let's go ahead and set up an equation. What I'm going to do is I'm going to just choose A. That's the one I'm trying to find, and I'm going to write an equation that has A in it. And I could use maybe the sine function, right? So opposite over hypotenuse. I could use the tangent over the hypotenuse equation. I have a lot of choices here. I could use opposite over adjacent. Either way. So I could use any one of my trig functions to find what A is, as long as A is the unknown. Let's do sine. So I have the sine of A is equal to 6 over 10. Okay? So I'm going to go ahead and reduce that to 3/5. Okay, so now I need to get that A by itself. I'm looking for the angle A equals that. So I have to think of a way of getting rid of that SIN. So if you look on your calculator, just above sine, so if you look just above my sine key, you'll see this, whoops, my thing disappeared. You'll see that sine with a little -1. That's the opposite, okay? Now watch my artwork here. You're going to do this exact same thing on your paper. You're going to take and put parentheses around both pieces, left side and right side. Then you're going to write sine -1 and sine -1. Okay, so this one right here has to be on this side. This one has to be on this side. These two things are opposites of each other, so they cancel each other out, leaving me the A on this side. Okay, all I'm doing is on this paper. So on the right hand side, I'm going to have the sine inverse 3 over 5. Okay, just like that. And now it's time for my calculator. So now I'm just going to plug that in. So to get that yellow there, I'm going to do second sine, and then 3 divided by 5, close, and it's going to, and so then it's going to give me, I'm in the middle with my enter, there we go, 36.9 degrees. 36.9 degrees for that angle. Okay, now I could do all that for B, but I really don't need to. I'm just going to use the triangle sum theorem to find that missing angle B. All right, once I find that one acute, I can find the other. So on your homework tonight, you're going to have to do this. So when you get to having to find the angle, you come back to your notes, you come back to this video to look at what artwork that you need to do there. Now, I could have chose the equation cosine, and then I would do cosine inverse on both sides and then enter it into my calculator. That's it. Let's go ahead and write your summary and move on to our homework. All right, so I'll scroll in so you can see these things. Some review questions down towards the bottom. So on that first one, you're just writing the fractions. You're not solving for anything. You're just writing the fractions. On number 2, you're actually finding A. Number 3, you're finding the angle like we just did. Number 4, that is a review question. And number 5 is a review question. All right, good luck, everybody.